Hello? This time, I'm going to learn about circles and lines. First, the perpendicular drawn from the center of the circle to the chord bisects the chord. That is, there is a circle. The center of the circle is called O, and if the line segment AB is called a chord. Then, if we drop a perpendicular from point O to line segment AB and call that point M, the lengths of AM and MB will be equal. Let's solve a problem. Let's take a look at the triangle ACM. The triangle ACM is a right triangle. So, we can find the length of line segment AM using the Pythagorean theorem. This is how it will be. Then the length of line segment AM will be 8. The length of line segment AM is equal to the length of line segment BM. So, the length of line segment BM also becomes 8. Triangle OBM is also a right triangle. So, I will find the length of x using the Pythagorean theorem. First, the length of line segment OC is equal to the length of line segment OB. So, the length of line segment OC becomes x. Then, the length of line segment OM will be x minus 4. Now, by applying the Pythagorean theorem, it would be calculated like this. Then the value of x will be 10. Let's look at one more problem. First, I'll mark the center of the circle and call it O. Then this length will all be the radius, right? Let's call this length all x. Then this length will be x minus 6. Now we will look at triangle IOM. Because it's a right triangle, I will apply the Pythagorean theorem. So if you calculate it, this will happen. 12x equals 180. Then the value of x will be 15. The radius of the circle also becomes 15. This is the second story of circles and lines. The lengths of two chords that are equidistant from the center in a circle are equal. There is a 1. There are two chords. Then, if the distance from the center of the circle to the two chords is the same, the lengths of the two chords will be the same. Then, shall we look at another problem related to this? First, it was said that the lengths of the two chords are equal. Then the lengths of the paths from the center of the circle to the two chords are the same. So, drop the perpendicular from point O to line segment AB. Let's call that point N. Then the length of the line segment ON will be 5. Now, to find the length of line segment AB, I will use the Pythagorean theorem again. First, if we find the length of N, this is how it will be. Then, the length of line segment AB is twice the length of AN. It becomes 10. Now, if we calculate the area of the triangle, this is how the calculation works. So the answer is 25. How was it? If you liked it, please subscribe, like, and set notifications. Let's meet again next time with the tangent of the circle.